What if I told you that while you were sleeping, robots were quietly mastering one of humanity's greatest athletic challenges? In April 2024, something extraordinary happened in China that most of the world barely noticed. A humanoid robot named Tiangong Ultra completed a half marathon, running 21 kilometers in just 2 hours and 40 minutes. Let that sink in for a moment. A machine with legs, running continuously for nearly 3 hours, navigating terrain, maintaining balance, and crossing a finish line that until recently seemed decades away from robot capabilities. This isn't science fiction. This is happening now. And it might just be the most important robot you've never heard of. For decades, the holy grail of robotics has been creating machines that move like us on 2 legs, balancing dynamically, navigating uneven terrain. Companies like Boston Dynamics have shown us impressive but often limited demonstrations. But what China's Beijing Humanoid Robot Innovation Center has achieved with Tiangong Ultra represents something entirely different: endurance, reliability, and a glimpse of robots truly entering our world. At a special robotics demonstration event in Beijing, Tiangong Ultra became the first humanoid robot to complete a half-marathon distance of 21 kilometers. The robot finished the course in 2 hours and 40 minutes, not breaking any human records, but absolutely shattering what we thought robots were capable of just a few years ago. To put this in perspective, the best human marathon runners finish in just over 2 hours, while a casual jogger might complete it in 4 to 5 hours. Tiangong Ultra's time puts it squarely in the realm of human capability, though it did require 3 battery swaps along the way. Let's break down what makes this achievement so remarkable. First, the robot maintained balance while running continuously for hours. Anyone who's studied robotics knows that bipedal locomotion, walking on 2 legs, is incredibly complex. Each step requires precisely timed weight shifts, ankle adjustments, and constant feedback from sensors. Now multiply that challenge by running, where both feet leave the ground simultaneously, and the margin for error becomes microscopic. Second, the endurance factor. Most advanced robots we've seen can perform impressive feats for short bursts, maybe minutes at a time. Tiangong Ultra operated continuously for nearly 3 hours while managing heat buildup, battery consumption, and mechanical wear, problems that have plagued robotics for decades. Third, and perhaps most impressively, the robot navigated real-world terrain variations. This wasn't a perfectly flat indoor track but included slight inclines, declines, and surface changes that required real-time adjustments. Let's get into the specs that make Tiangong Ultra such a remarkable machine. Standing 1.8 meters tall, that's about 5 foot 11 inches, this robot has human-like proportions but weighs significantly less at just 55 kilograms, or 121 pounds. This lightweight design is crucial for its performance. Tiangong Ultra can reach speeds of up to 12 kilometers per hour, not Olympic sprinter fast, but definitely a decent jogging pace for a human. For comparison, Tesla's Optimus robot tops out at about 8 kilometers per hour, and Boston Dynamics Atlas, which is famous for its park hour videos, maxes out around 4.5 kilometers per hour in sustained movement. The magic happens in the robot's joints and thermal management system. One of the biggest challenges in robotics is heat buildup. Motors generate substantial heat during continuous operation, which can cause performance degradation or complete failure. Tiangong Ultra employs an advanced air cooling system combined with phase-change materials that absorb heat during operation. The robot's brain is equally impressive. Its Hu-Isekaiwu motion control system performs 550 operations per second, allowing it to maintain balance even on inclines up to 9 degrees and navigate across gravel terrain. This is powered by what the developers call memory-based reinforcement imitation learning. Essentially, the robot learns human movement patterns through motion capture data and adapts them to its own frame. For sensing its environment, Tiangong Ultra utilizes dual 3D vision cameras, a 6-axis inertial measurement unit, similar to what helps your smartphone know which way is up, and pressure sensors in its feet that help it understand the terrain it's walking on. Perhaps most critically for real-world applications, the robot features a modular 500 watt-hour battery system that can be hot-swapped. During the marathon, the team swapped batteries 3 times, showing that while continuous operation requires intervention, the robot can quickly resume operation after a battery change. The company's behind the breakthrough. The development of Tiangong Ultra represents something we're seeing more frequently in cutting-edge technology: strategic collaboration between industry giants and government entities. The Beijing Humanoid Robot Innovation Center is a consortium comprising several major players. UBTECH, which is China's largest service robotics company and has been developing humanoid robots for years with their Walker series. Xiaomi, the electronics giant known primarily for smartphones but rapidly expanding into other technology areas. Beijing E-Town International Investment, a state-owned enterprise that provides government backing and resources. This collaboration brings complementary strengths to the table. UBTECH contributes their expertise in servo motors and joint control algorithms. Xiaomi brings their miniaturized motor technology and battery management systems derived from their smartphone division. The state partners provide access to specialized materials and testing facilities. This kind of consolidated effort represents China's systematic approach to technological development, combining private sector innovation with state-level coordination and funding. It's a model that's proven effective in areas like artificial intelligence and renewable energy, and now we're seeing it applied to humanoid robotics. To understand Tiangong Ultra's place in the robotics landscape, let's compare it with its counterparts. Tesla's Optimus, unveiled by Elon Musk's company, is still in prototype stage. It's reported to have a top speed of about 8 km per hour, with a 90-minute runtime and a 10-kilogram payload capacity. While slower than Tiangong Ultra, Optimus may have an edge in autonomous navigation thanks to Tesla's advanced computer vision systems derived from their automotive technology. Boston Dynamics' Atlas is perhaps the most famous humanoid robot in the world thanks to viral videos showing it doing park hour and backflips. However, Atlas is primarily a research platform rather than a commercial product. It has a maximum walking speed of around 4.5 km per hour, a runtime of about 30 minutes, and can carry approximately 11 kilograms. While Atlas excels at dynamic movements and acrobatics, it hasn't demonstrated the endurance capabilities of Tiangong Ultra. Where Tiangong Ultra really stands out is in its combination of speed, endurance, and potential for commercial deployment. The modular battery design allowing for rapid swaps is a pragmatic approach to the energy limitations that have held back robotics. This focus on practical, real-world operation rather than just laboratory demonstrations signals a shift in how we might see robots deployed in the near future. So what does all this mean for us? Are we witnessing the dawn of the robot age that science fiction has promised for decades? The truth is both more mundane and more profound. Tiangong Ultra represents not a sudden breakthrough, but the culmination of decades of incremental advances in materials, computing, battery technology, and artificial intelligence. What's new is seeing these elements combined in a system reliable enough to perform complex physical tasks for extended periods. The half-marathon achievement is significant not because robots will be competing in Olympic events anytime soon, but because it demonstrates the endurance, reliability, and adaptability that have been the missing pieces in the robotics puzzle. When robots can operate for hours in unpredictable environments, the range of tasks they can perform expands dramatically. Whether this technology develops primarily in China or becomes a truly global phenomenon will depend on how Western companies and governments respond to the challenge. Boston Dynamics, Tesla, and other players have shown impressive capabilities but have yet to demonstrate the endurance and reliability showcased by Tiangong Ultra. What's your take on these developments? Are you excited about the potential of humanoid robots or concerned about their implications? Let me know in the comments below.